Mr. Beck does your homework. Question 14, homework 14, question number 6. A 363 kilogram mass is brought close to a second mass of 142 kilograms. So I've got one mass that is being brought closer to a second mass. So this one, I will put a hand on this one. So here's the hand holding onto this one. Okay. This one is being brought close to that one. So this is 363 kilograms. And this one is 142 kilograms. On a frictional surface with coefficient of friction of 1, wow, I'm lucky. At what distance will the second mass begin to slide towards the first mass? Well, what are the forces on this one? I've got a normal force of gravity and a typical force of gravity this way. I've got a normal force going this way. I'm going to have a force of friction pulling this way, and I'm going to have a universal gravitational force, F capital G, pulling that direction. So what I'm going to need to know is when this mass is close enough, then this gravitational attraction to this mass will balance out the force of friction, and when that happens, the block will start to slide. So at what distance will the second mass begin to slide towards the first mass? So what I know is that I want to set the gravitational force between the two masses equal to the force of friction. So I'm going to write Fg equals Ff. This universal gravitation equals the force of friction. Well, the universal gravitation is going to be g times the first mass times the second mass divided by the distance between them squared. I'm solving for r. R is what I'm looking for. Equals the force of friction, and the force of friction is mu times the normal force. But in this case, the normal force is going to be the force of gravity, which is going to be this mass over here times g. This mass is m2, okay? This is m1, this is m2, m1 and m2, so I'm just going to call them 1 and 2. So this is going to be g m1 m2 over r squared equals mu times mg. And this is m2. Well, you'll notice that m2 kind of cancels out here. So I've got this mass over here that I'm interested in, and then mu times gravity over here. So if I multiply by r squared and divide by mu g, I will get r squared equals g times the mass on the left, which I called mass 1, divided by mu times the acceleration of gravity, g, which is 10. So that's going to be r squared. So I can follow this through and say that my distance between them when they're equal is going to be the square root of g times my mass on the left divided by my mu times the acceleration of gravity. Acceleration is 9.8 for gravity. So for me, my r is going to be the square root of 6.67259 times 10 to the minus 11 times the mass on the left, for me, is 363, divided by the mu, which for me just happened to be 1, I don't know why, and g is going to be 9.8. So that'll give me the distance between them when the thing starts to slide, because I'm dealing with when this force of friction is going to equal this force of universal gravitation.